Rowdy Lemon here, and today I'm going to show you how to eject shell casings in your 2D shooting game. So the first thing I'm going to do to start creating a shell casing that gets ejected from your gun when you're firing is grab this art asset, which I've already loaded into my game. I'm just going to drag it into the scene. Cool, and I'm going to rename it to be shell case. Awesome. Next, I'm going to add a rigid body to it. And so rigid bodies in Unity are used to when you're interacting with physics. And we're going to use physics to kind of simulate what a shell casing kind of looks like. So here I'm just going to say rigid body 2D since we're in a 2D game. I'm going to set gravity scale to 0 because we don't want to use any gravity. And I think that's as much as we need for that. And the next thing is just to create a script to govern this bullet. So in our scripts folder, I'm going to go ahead and right click, create a C# script, and I'm actually just going to call it shellcase. Oop, there it goes. Cool. Now I'm just going to open that up and start writing the script for it. All right, the first thing we're going to need to do is define a couple variables here at the top. So I'll start with a public float start Y position. So that's the position in the Y direction that the bullet is ejected from the gun. So that'll be basically right in line with where our gun is. Next, we'll need a public float Y V0. So our V0 is just a fancy way of saying initial velocity. So this will be our initial velocity in the Y direction. Similarly, we'll need a X V0 as well. And we're also going to need an acceleration. And since we're going to try and look kind of like how gravity does, we're going to use negative 9.8 meters per second squared as the acceleration due to gravity. We're also going to need a reference to our rigid body. So public rigid body 2D. I'm going to go ahead and call that RB. Next, we're going to need to keep track of how much time has elapsed since the bullet's been ejected. So we'll create a private variable. So private float, and this will be velocity time. So how much time has gone by, and then we'll also need a rotation speed as well, because I think we're going to want to try and make it so that the shells kind of spin a little bit as they come out of the gun. So we'll call that 400, or we'll do 400. All right, I think that's mostly. Oh, and then we're also going to need some kind of offset from the ground. I'm not sure what that is. Let me try and figure that out real quick. All right, off camera, I went ahead and just measured the distance basically from where the gun currently is to where the bottom of my character's feet are, and it ended up being more or less 0.5. So our offset will be negative 0.5. Perfect. All right, so now in our start function, let's go ahead and set some of these things up. So we have first our start Y position. So that'll actually just be equal to our current transform dot position dot Y. So wherever our bullet is instantiated, the current Y position of our bullet is going to be our start Y position. And then we're also going to want to set our rigid body's initial velocity. So rb.velocity is equal to a new vector 2, and that'll be x v0 and y v0 for our initial x and y velocities. Awesome. Next, we're not going to use update. Instead, we're going to use something called fixed update, which we want to use whenever we're interacting with physics objects. So private void fixed update. All right, and I think what I'm actually going to do is create a helper function that we're just going to call inside of fixed update, and I think that's going to be called acceleration, because we're going to update our acceleration every fixed update. And I'll define that helper function right here. So that'll be a private void acceleration. The first thing we want to do in the acceleration function is update our velocity time. So we want to keep track of how much time has elapsed since we spawned our shell casing. So velocity time, and we're just going to plus equal that to time dot fixed delta time. So that's how we'll keep track of that. Next, we want to basically, if the magnitude of our velocity is such that it's almost like basically zero, instead of continuing to do anything, we'll just set it straight up right back to zero. So we'll say if our rigid body velocity dot magnitude is less than some small number, we'll do 0.5. We want to set our rigid body velocity just to vector2 dot 0. All right, and then we'll just return right after that. So this will represent basically our bullet shell casing after it's come to rest on the ground, and that's why we're returning right after it. Next though, what we'll want to do is all the physics related to it flying out of the shell casing and bouncing around and spinning. So first let's do the shell casing spinning in the air. So to do that, I'm just going to do a transform. So we're going to grab our transform and we're going to rotate it. And what we're going to pass in is 0, 0, oops. And then we're going to pass in our rotation speed, and we're going to multiply that by time dot fixed delta time. Perfect. And that should take care of our bullet rotating as it's ejected, or bullet shell casing rather. Next, let's get into the fun bits of actually moving it up and down. So let's see. Start with if our transform dot position dot y is less than or equal to our start y position plus our offset. So if we're at the ground, and we'll say if our rb dot velocity dot y is less than 0, we want to make some changes. So we'll say float y velocity is equal to negative rigid body dot velocity dot y, and then we don't want it just to maintain the exact same velocity. So basically this is after the bullets hit the ground, we want it to bounce, right? So that's why we're taking the negative of our velocity. But in addition to that, we also probably want to lose some of our velocity as we hit the ground, so we're not bouncing straight back up to almost right where we were ejected from. We want to kind of be a little bit smaller. So I'm going to multiply that by 0.25. So we're going to be a fourth as, oh, did I misspell velocity? Yes, I did. So we're going to lose 3/4 of our velocity whenever we hit the ground in our y direction. We're going to do the exact same thing for our x. So x velocity is equal to, except we don't need to be jumping all around negative with this because we want to keep moving in the same x direction. So rb dot velocity dot x, and then multiply that by 0.25f. Let's see, we'll set our rigid body dot velocity equal to a new vector2. Oops. If I can type right. And then we'll pass in those values we just created. Velocity, y velocity. Also, because we're going to be using our velocity time to determine our current acceleration, what we want to do is actually, because we've hit the ground, we don't want to continue accelerating at the same exact speed. We need to reset our acceleration. So to do that, I'm just going to set velocity time equal to 0. Perfect. Now, this is capturing the case where we hit the ground. So we hit the ground, we completely set our y velocity in the opposite direction because we're going to be, if we're coming down, we hit the ground, we want to be going back up. We need to capture all other the other case, right? So if we're not hitting the ground, what do? Well, we need to set our current y velocity. So to do that, what we'll do is I'll create a new float rather, call that y velocity, and we'll set that equal to our rigid body velocity, y, and we'll add that to our acceleration, and we're going to multiply our acceleration by our velocity time. So we accelerate faster and faster as more time has passed since we've been flying through the air. Next, what we'll do is we'll just set our rigid body velocity equal to a new vector 2, and to that we're going to pass our x v naught, because our x velocity shouldn't change at all, but our y velocity is changing due to acceleration. So, and I think that should make up all that we need for ejecting a shell case and governing it as it flies through the air. So let's go add this script to our shell case and see if it works. I actually just realized I made a mistake earlier, so we don't want to actually set this to our initial x velocity, because then it will never actually slow down in the x direction, because we'd just be setting it back to what our initial x velocity was, whereas here we're obviously slowing it down every time it bounces. So what we really want to do is set this equal to our rb.velocity.x. So whatever our current x velocity is, just maintain whatever that current velocity is in the x direction. Cool. All right, now we can go see if this is going to work in Unity. So I'm just going to grab that shell case script, drag it, and drop it onto our shell case art object, game object right here. And let's actually go ahead and drag that over to where the gun is, where it'll actually be ejected from the gun. It's actually behind everything. So let's go ahead and put it on top. So, and to do that, we just need to adjust the order and layer. So I'm just going to put that to something like 6, so it always shows up on top. Cool. So now when it gets ejected, we'll actually be able to see it. Now let's go ahead and set some defaults. So let's see. Let's start with our yv naught. So let's say our initial velocity in the y direction, we want it to probably fly up first, right? So we want this to be positive. So we'll start with something like 8. And we'll do the same thing for our x velocity, but let's go in the negative direction so it flies in the opposite direction of our gun currently. So we'll do -8 here. And then our rigid body, we need to make sure we drag. So we can just do that by click, drag, drop that right there. Cool. So now our shell case script's all set up. I think if I hit play, we should see something fun. Let's see. Excellent. So now you can see the shell case flies out of the gun and lands right here after bouncing a couple times. I think that's looking pretty good. So now we need to adjust our weapon script so that it has a reference to this shell case and can fire it. First thing, we're going to want to create a prefab for the shell case. So I'm going to go to my prefabs folder. I'm just going to click, drag, drop our shell case into there. Excellent. So now I'm going to open our weapon script and add a reference to the shell case in there. So let's add a reference to that prefab we just created. So game object, and we're going to call it shell. Now, down here where we're attacking, this is where we're going to want to instantiate a shell. But what I'm going to do is I'm actually going to create a helper function to do that. So let's create a private void, and we'll call it eject shell. And so what we want to do is first create a game object. We're going to call it ejected shell. And what we're going to do is we're going to instantiate that shell that we prefab that we have a reference to at the top, and we're going to instantiate it at our transform.position, so in the center of the gun, and we're going to instantiate it with a quaternion.identity rotation, and that's basically a way of saying I don't really care about the rotation, just whatever this basic rotation is. Cool. Next, we would need to calculate the initial x and y velocities. Now, to add some spice to it, I'm actually going to do a random number. So what we'll do is we'll do a float. So we'll do x v naught is equal to a random dot range, and we're going to choose some values between, let's see, let's do 5 and 10 f. So that's how fast our initial velocity is in the x direction, and then we'll do something similar for our y v naught. Let's do the same thing, because I think that looks pretty good. 5 and 10f. Cool. Now we need to make sure, based on where our gun is currently pointing, we are ejecting our shells in the correct direction. So we're going to use our fire point to determine what direction we're currently aiming in. So to do that, what we'll do is we'll say if not, we'll say fire point dot rotation dot Euler angles dot z is greater than or equal to, and we want to rotate basically, so if our character's right here, we want to rotate, or we want this to set it to negative if we're facing in this direction, right? So that'll be from 90 degrees to 270 degrees. So if our z is greater than 90 and our fire point dot rotation dot Euler angles is less than 270, let's take our xv naught and just multiply it by -1, and that'll reverse the current x velocity. Cool. Now the last thing we need to do is actually set those velocities on the ejected shell. So we'll grab our ejected shell, we'll say dot get component shell case dot xv naught, set that equal to the xv naught we calculated, and then we want to do the exact same thing for our y. Cool. Now the last thing we need to do is actually call this helper function in when we're attacking. So we'll just call eject shell right there. Nice. Let's go back in Unity and make sure everything's hooked up. Oh wait, what's going on down here? Oh, rotate. Oh, .z. All right, now let's go back to Unity. So I can actually remove this shell case prefab from the scene. I don't need it anymore. So I'm just going to, not duplicate it, delete it. And now on the weapon, we have a shell prefab that we can populate there. So I'm going to grab our shell case prefab from our prefabs folder, drag and drop that into there. Cool. And I think that should take care of everything. Let's hit play and see what goes on. Excellent. As you can see, shell cases are now being ejected from our gun as we fire. Woo! Once again, thank you for watching. If you enjoyed the video, subscribe, drop a like, leave a comment, let me know what you think, and stay tuned for more game development content in the future.